what we're going to talk about today is, how to build trustworthy network automation and look at it from more like a conceptual point and try to bring that as much as possible to how do we actually do that. So I guess this slide probably not much to say that, Vincent already talked about it, but such that maybe at Optimal we're actually, building a product called InfraHub. It's a next generation source of truth. We like to call that a infrastructure data management platform, and try to put everything I learned in the last 12 years building automation into that. So check it out if you're interested. So maybe first, let's talk about why we need to talk about trust. And in my experience, I think, I've seen a lot of automation projects that failed, not because we could not implement it, but because no one wanted actually to use them. Like there's a lot of projects where we put a lot of resources building very complex system, just to learn that at the end of the day, no one from the operation team wants to use them, and they just go around the tool and do the things they were doing all around. Like it just happened over and over again. And in my perspective, it's really about trust. It's like we have to build trust. The user has to build trust, especially around automation. Like if you don't have trust, no one is going to use your tool. That's why it's so important. Like to put an example, if I give you a black box with a button on and say, hey, press, and you're going to have your network upgraded, how many of you are going to press on that button? My guess is probably nobody, because I would not. Like that would just sound so scary. And so you might say, but why would anyone actually build a box like that with just a red button? That's stupid. Like no one should do that. But the truth is, that's what most of us builders of automations have been doing, I think, because we're really it's more of a craftsmanship in many ways. And it's just that for the guy that actually built that automation, it doesn't look like a black box. For him or her, it actually looks like a system that he fully understands, that is very complex, is usually very proud of, and he exactly understands what's happening. And so there's this big disconnect between builders and users that I think are really leading to a lot of the challenges in our space. And that's why, again, because I've been building personally so many of those black boxes without even realizing it, it's like, okay, maybe it's time I try to actually share of that with the team. And so I think to really build trustworthy automations, it's really the iceberg image where we usually focus on making it work. Like I need to build something to upgrade the network. I'm going to put all my efforts into make sure that in this one, positive situation, like happy path, everything is working and then done. But the truth is there's all of those other aspects around. You need to make it predictable. You need to make it transparent, from the user. It needs to be reliable, human-friendly, and manageable in a way that's, to me, like it's usually what we forget. So if we take another way to represent that, if I was being tasked to build a car to go from A to B, I could very much build something like that. Like it's technically a car, it can go to A to B, but it doesn't have lights, it doesn't have mirrors, not even sure if it has brakes, but it can go there, it doesn't have door. And I think that's, again, what we're building, but you can see that a real car, a car you will trust, will actually look more like that. And the main difference between those two cars is this one is reliable, this one you understand what's going to happen, this one you will actually put your family into, where the other one you will not. So I extracted those 6 principles. Like if we want to build trustworthy automation, it's very important to, so that the user understand what's going to happen and it's predictable, that they have good ways to implement that there's some notion of transparency, like we don't want to have that black box. Of course, it has to be simple, meaning it should not be overly complicated with things all over the place, and reliable and human-friendly. So what I'm going to try in this presentation is start from those and actually look at what are the different concepts and techniques and things like that you can implement. Now, while this talk might sound like I'm actually targeting more like builders of automation, I think as user, we need also the users to raise the bar and say, hey, I need that. I need you guys to provide this type of features or this type of things. So I'm hoping it's more like giving you language and vocabulary to actually have those discussions, whether you're a builder or a user, to overall improve how we're building tools and having tools being used overall. Just disclaimer, like if you look at my garage, you'll find a lot of cars that don't have doors, don't have wheels, some don't have engines. Like this shit is really hard. So I'm not pretending that it's easy, and all of those high-level concepts are actually really hard to apply. Even today, I could very much, forget and build a car that doesn't have doors. It takes a lot of efforts, but I think, understanding what we need, where we need to go is the most important part. So let's get started, and hopefully along the way, we'll make better tools and overall make our industry better. So now we talk about the higher level principle, and now I want to talk about three, what I call design principle. I think is super important, and I noticed that a lot of network engineers that become user of automations or network engineers that become builder of automation don't necessarily always know. I think it's very important, like to me, like foundational design principle. And then we'll talk about more like three technology that are actually enabling those principles. So the first one is idempotency. Idempotency is so important to how we build actually reliable automations. This concept to say that every time you do an operation, if you do it multiple times, you will always have the same result. And I'll go over it quickly because we'll talk about it, multiple times throughout the presentation. But it's a cornerstone of reliability and how we actually build automation. Now I usually say idempotency. At least for me, it's hard to pronounce. It's actually really hard to explain what it does. But what's important to understand, it's actually really hard to build. Like building a true idempotent system is really hard. And it's mainly because it's about state management. And in our field, state management is the hardest. So just an example, like DHCP is actually, to me, the best example of idempotency. Like as a client, if you have a client that is not idempotent, he will ask for an IP address 3 times, they will get 3 different IPs. Where, because DHCP is idempotent from the client point of view, the client just makes 3 requests, and then you always get the same IP. And here again, it's all about the states. What we see here is that there's no complexity on the client side. And I think, to me, that's what's very important is like the client doesn't have to understand the previous states. Did he already requested something? He doesn't have to take care of all of that. Like the client is very simple. I just need an IP. And then the complexity is actually on the server side. And the server maintains the state here. And because the server has this complexity, then we can have very reliable clients and workflow. And it's just an example. Again, I'm trying to help that, but we'll get back to that and talk more about it. The second one is dry run. Dry run is the idea that we need to show to the users exactly what will happen before we actually do that. And as you can imagine, it's a game changer in terms of actually building confidence. So if we go back to the black box earlier, if you actually had 2 buttons on that box, one red one that say if you press, it will happen. Another one, a green one that you say no is safe, and say if you press on it, we're just going to show you everything that will happen without making any changes. That suddenly that black box, I'm sure a lot of you will actually press that green button. So this concept of dry run, being able to show all of that is super important. And it's really about like, hey, show me the diff of what's going to happen, and then you make the decision, yes or no, I want to do that. Just to bring also an example, like it's actually something that is already built into a lot of the tools that we're using, like Ansible. There's options that you can actually say, I want to, by default, it's not enabled, but you can say, I want a diff or a check, and you'll be able generally to see, like, for example, what are the changes that will be pushed to a config files, or what are the changes, like, tools like Terraform, they actually have that built in, like in Terraform. Dry mode is mandatory. Like you cannot have a module that doesn't support that. And we'll talk more about it in a minute. And same with Kubernetes. So it's something that's the tools that are widely used, you see that they already have that. So it's also something to integrate and consider as you're building things. And the third design principle is transactional. This idea that if we have multiple changes that needs to happen at a given time, it's very important that either all of them happen or none of them happen. Like the worst would be if you actually execute a workflow and then you leave your system in a completely unpredictable state, and now you have to clean up everything manually. I mean, that's the worst. That's the nightmare that everyone in operations don't want to manage. And so it's very important to have this transactional system. So again, I'll go quickly through that because actually we're going to talk more about the implementation of that in the next section. But I think what's important to keep in mind is idempotency, dry run, transactional, they're actually very related to each other. Like it's by definition much easier to provide dry run if you have an idempotent system. Like, Terraform is by definition idempotent and it provides the dry run because it has this state approach. And I will say, I'm not sure if they're fully transactional. They could potentially leave your system in a bad state. But the point is, like, they're individual topics, and you could read a lot on each of them, but they're actually very connected when it comes to the implementation. Now let's try to, you're like, okay, that sounds great, but how do I actually implement that? How do I actually make that happen? And to me, there's three, I call tools or technology, I don't know how we call that are very important, that directly connect to that. And so we're gonna talk more about them. The first one is this notion of declarative versus imperative. That again is, I think everyone that I've seen that really start into automation as a user or as a builder, you usually start with the imperative method, because imperative is just we duplicate what we've been doing as human as a function of steps and action, and we're just gonna try to automate that, where the declarative is we're completely changing the game, and instead of focusing on how we do something, we focus on the what and more of the outcome. And it's, again, a real game changers into that. So if we look at that, again, on the left side, the imperative is, pretty much what you would do in CLI. I need to go in CLI, I need to enable mode, I need to configure that VLAN, I need this, and that, and there's a number of steps, where the declarative will be more, I want this VLAN configured on this interface, and I don't care how it's being done. Like, the tool will actually take care of that. And so what you actually see is that by definition, again, declarative and idempotency are, by definition, something that is declarative is kind of idempotent. But I thought that was very important to actually explain those two concepts separately, but they're definitely very tightly coupled to each other. If we go back to the tool, just so that you can position, tools like Kubernetes, Terraform, all the new tools, they're very much been embracing this declarative approach. Like, by definition, they are declarative. What I also found interesting is sometimes we forget, but actually the configuration of our network device are by definition a declarative model. Like, we don't have to tell the switch, hey, you need to add this config or add these things. Like, we just define the config and we let the devices apply that. On the imperative side, it's more like what mimic the CLI. So whether it's tools that are like NetMiko that technically apply the steps to the CLI manually, or CLI itself. The one that I found interesting is Ansible. There's a lot of haters and lovers of Ansible, I think, in our industry. And I think personally, the misunderstanding comes from the fact that Ansible can do both. And it really depends on, like, it's such a Swiss Army knife that can do everything, that you could actually use it in a completely declarative manner. And I think that's personally how I've always been using it. Or you could build the most crazy and complex shit ever, and then you'll have a completely different experience with it. And so just keep that in mind. Like, it's not so much about the tool, it's how you're actually using it. Another way to represent this imperative and declarative approach is, let's say that I want to implement a few imperative workflow. And usually, a workflow will have to touch different systems, whether it's switches or endpoints or things like that. But you can see here that, the more steps, the more systems you have to build, the more like complex your overall system is going to be. And to me, there's really this curve that says the more steps you have in your imperative workflow, the more complex it will be, the harder it will be to develop, the harder it will be to test. And overall, so that's the yellow line. And the red line is, I will say, the trust that users will have in your system is overly, is the opposite of that. It's like, the more steps you have in your workflow, you're almost guaranteed that user will not trust that because it just will become too complex. So if we come back to those early principles, it's not going to be simple, it's not going to be reliable, because every steps you had in your imperative workflow is an additional level of complexity. The other approach is, say, if we go with the declarative method, the big difference is here you usually have this, data system in the middle, whether you call it a source of truth, an intent store, Git. It's more like, because it's a declarative approach, you need to store what things needs to look like. And it kind of builds this level of abstractions between your workflow and the different system that you manage. And it actually really, like, now we see that the changes, they're actually managed more independently by agents, or, that could be smaller workflow. The term doesn't really matter. That could be Terraform at the bottom, that could be Kubernetes, that could be Ansible, on each of them. But the concept is the changes are kind of broken down into smaller steps that becomes easier to develop, to test, to validate, and you focus more on the state than this end-to-end workflow. And again, some of you are probably very familiar with that, but I've seen so many people that don't understand that, and as they're actually building systems, they naturally go to more of the imperative approach, and they don't think of how they can actually build. Like, to me, it's like we try to make it declarative if you can, and if you cannot, then you can make it more of an imperative system. And I think there's actually some very interesting papers from Google's where they explain also like how they migrated a lot of their internal workflow 5-10 years ago into that. At the end of the day, it's not that it has to be 100% one way or the other. It's just tools. Like, it's just a way to implement. There's some processes that will be very complicated that needs to be done in a more imperative way because you need to manage the transition of states. There's some that can be done in a more declarative way. So it's really things to keep in mind. The second technology I think has been really important is version control. We've seen the rise of infrastructure as code and GitHubs, and in many ways, all of that brings back to this concept of version control. And version control, to me, it's really this idea that a change will be prepared in isolation. It will have the ability to validate that change, and then we'll be able to review before we actually apply that. Who doesn't want that? Like, that's, I think, the dream of everyone in operation. And if we look at the way it works, it's usually like there's this concept of branch, and then we're going to have a branch, and a branch will be able to make a change completely isolated from the rest of the system. We'll have the ability to do run of validation, and then we can review, and then we can deploy, and then we have multiple systems. In my experience, there's really a big division. Like, there's people that get version control because they've been using Git, and they learn how to use that, and there's still a lot of people in our industry that don't understand. I think everyone, especially in the management, or that have never really had to get there and dirty, they heard those terms, they will tell you, yes, I know, but the truth is they probably don't understand how big of a game changer it is in terms of collaborations and review and the mindsets. Like, time and time again, I've seen different organizations where there's a big disconnect, where people don't and say, oh, Git is just for the code. It's not something that I can use. But at the end of the day, to me, it's really about traceability, audit, review, and all of that. Now, historically, it's something that was very specific to code and Git. I think what's very exciting is we're actually seeing now version control that is coming more to applications, like enterprise applications. We're able to apply the same concepts to your database, to your data, to have those same concept of branches and isolations and review pretty much on any application that we're building nowadays. And it's coming, there's a lot of different initiatives. So I think it's very exciting and very important that we keep that in mind. If we actually bring that back, I forgot on the previous section, but if we bring that back to the design principle, by definition, version control, it's usually focusing on state, because we usually use that also like as a way where we actually define the expected state. So it's idempotent. It also has these concepts where usually between the branch and the main branch, you will be able to create a diff. So it has this dry run capability built in. And because we apply a commit at a given time, it also has this transactional aspect. So by definition, version control is like it implements all the design principle that we've been talking earlier. And the last one I want to talk about is testing. So I'll go over this one very quickly because I feel like it's such a big topic, and there's a lot of things we can say on it. But my main point here is like testing is something that is a choice and that needs to be incorporated into the design. I think many times, if we have a system that was not easy to test, it's because it probably should be done differently. Like and we can very much have systems that are very hard to test because it was a design choice. Like I heard many times, like, oh, my system's too complex, I cannot test that, and we take that as a fact of implementation, and like, oh, I'm just not gonna do that. Where I think it actually needs to be as a primary requirement from the beginning, so that we can actually do that. Because if we're not building reliable system, it's just never gonna work, and we're never gonna be able to build trust with our users. Just a little bit again of, I'm not planning on, but so we have the same vocabulary. When we come about texting, there's the unit test, there's the integration test, there's the end-to-end test, testing different things. We don't like, if you're actually writing software and code, you definitely want a unit test. Then as you start assembling different projects together, you want integration test. And I think the one we should always have into our as an option is the end-to-end test. Now, the higher you go in the pyramid, the more complex it will be to implement, the more time it will take to actually build those tests, run those tests. So you always want to try to go as low as you can in this pyramid to implement that. So again, not planning on pretending to go very deep on this topic because it's such an important one. But also keep in mind, like every time you have two options. So either you put more efforts into building the tools and building the testing, or that means you actually need to rewrite and resync your workflow. So for example, take a very complex imperative workflow that has 25 steps. If you're trying to test that, it's gonna be a nightmare. And you're like, I cannot do that, and it's too complex, but it's so critical to my environments, I have no other choice than you use that. But maybe you could actually rebuild that workflow and break it down into fewer steps, having more declarative approach, and then suddenly that becomes a much more testable system. So again, few things to keep in mind. So as the last section, I wanted to try to cover, it's a bit of a bit everything together. We'll go from different slides without a lot of transition, but try to talk more about, okay, what can you actually do tomorrow to implement some of that if you're more of a builder. The first one is, personally, I think it's super important to, when I was network to code, we will always use this term and say, like, you need to integrate what you can and build what you must. Like, there's always going to be things that are very specific to your business that you will have to implement on your own and put the resources. There's no other choice. But everything else, you should put a lot of efforts to make sure that, there's a lot of frameworks out there. There's a lot of tools that exist. Like, I think we're past, except if you're Meta or Google, where you can 100% develop everything internally because you have an army of people and very smart people. Most organizations I've seen, they just don't have the resources for that. But yet, I've seen so many of us, me including, the building cars that don't have door, because from the beginning we just underestimated how much hard work it would be to actually build that. So think of really, to me, infrastructure automation is a system design. It's composed of so many building blocks, and there's a huge opportunity nowadays to integrate those building blocks and reuse what they're building and not have to implement like, how many of us have built like our own orchestration system? Like I certainly built a few too many. So the second one is, as you actually pick the tools, make sure that you actually look for something that supports declarative behaviors, that will make it easy for you to implement idempotency, that has the right interface so that you can easily integrate that into your testing stack, that has the right logging. Like, think of all those principles and like, okay, if I pick this system, how hard or easy is it going to be for me to achieve that? I think it's often something like we focus too much on just the functional aspect, and then later on realize that it's really hard to actually integrate. And I've seen, again, because we're more of a craftsmanship, I think, in many projects in our industry yet, that there's vast differences across the different tools that you have out there. Some of them look, great as a user, but then the insight in terms of like how you can actually integrate and test can be vastly different. So completely changing way to look at that. To me, something that is super important, and it's a wider topic. I'm not going to cover it all here, but this idea that we need to classify the data. I'm going to assume that I convinced you when you went with more of a declarative approach. You have a source of truth. You have everything in there. Welcome. Congratulations. Now, the next step is you need to classify everything with a role, a status, and a kind. And I think it's a complete game changer in how we build automation, but even more so to build trust, because this idea is that if you have that, then every workflow should be associated with a status, a role, and a type of device. So for example, if you have a workflow that upgrades devices, you want to make sure that by definition, it will only be applied on the devices that are in maintenance mode. That's the status. If it's a workflow that is for Arista device, that's the type. And if you have specific type of device, then that's the role. Like there's such strong connections between those three attributes, the status, the type, and the role, and the different workflow. And in many ways, to move from one status to the next, that means you have one specific workflow. Like you will have one workflow that takes your device from orders to provisions to operationals, and so on and so on. And so if you start thinking this way, you're kind of building trust in your tooling from the beginning. Here, it's going to be a little hard to read, but I try to actually show how, for example, on the Ansible playbook, you can actually even, if you have control of your inventory, you can if you look here, you can see that you even have the ability, for example, to filter out from the very, very beginning of this workflow every device that is not in maintenance mode. And then suddenly this workflow is safe by default, because even though it's a very disruptive workflow, you put a lot of guardrails into it. And it's like, you know that you're never going to apply a change outside of the maintenance windows if you're able to capture the maintenance windows in your inventory, in your source of truth system. And if you don't have control of your inventory, you can always just have that as the first task and implement some of that. So to me, those are some of those tricks that you can easily apply. And the last one that I found also, I found great success with this one, is this idea that we need to make sure that the default options are safe. And I think sometimes our tools, they're like Ansible. I personally like Ansible, but I think there's some things that I absolutely hate in there. Like for example, I told you can use this dry run mode, but it's not the default options. The user actually has to put --check and --diff. So if you're not careful, you might build your system and say, okay, I'm going to put in Confluence that you need to put those two options if you want to use the system in a safe way. 9, 10 out of 10 people will not read your documentation. Just accept that as a fact. And so what's going to happen is they will execute it the first time, everything will break, and then trust is lost. Where, if we assume that they're not going to read the documentation, there's actually a way that, we need to expose those multiple buttons. We need to organize things in a way that, I would say, create two playbooks, for example. One that has all the options completely hard-coded that they cannot destroy anything, make it with a name that is so explicit that they know that anything that is called check, they can always safely execute that, and just build the protections in the system itself. Because at the end of the day, even if they don't read the documentation, they're still going to blame the tools and they will never use it again. So, and so for me, hopefully that was helpful, and that, again, whether you're a builder or users, will help with the discussion and help us build more. So thank you very much.